Hi everybody. In the last video we ended by looking at this table of health outcomes, self-reported health outcomes, based on whether or not the individuals have health insurance. And it looks as though people with health insurance have increased health outcomes. But I kind of posed the question to you, which was, why might people with health insurance possibly have better health outcomes than those without health insurance? And because of these unobservable differences, we can't quite claim causality on health insurance and health outcomes. The problem is we have a whole bunch of people here in a health insurance group and a whole bunch of people here in a no health insurance group. But this is just reported data. This is not a randomized control trial. This is just if people have health insurance, then here's their health. If they don't, here's their health. We can think of a couple problems with that, particularly in the American healthcare system. Health insurance is often tied to employment. So if you have a job, you're going to have health insurance. If you have a job, you probably have more money. If you have more money, you might be able to buy healthier food and your health index might go up. So there are unobservable factors, and there are people within each of these groups who just aren't directly comparable with each other. And so to fully understand the causal effect, we have to do more than looking just at the summary statistics. This brings us to an important concept called the counterfactual. Okay, the counterfactual is what would have happened if a person, what would have happened if a person, but we could just as easily say with a person or a household or a company or a government or any other entity, what would have happened if a person would have been given the treatment instead of the control? Instead of the control. And so in our health insurance example, it's essentially if I'm provided health insurance, we can never, by definition, we can never be certain what my health outcomes would have been if I didn't have insurance. So I have insurance. There's no way to know what my health would be like without insurance, me as a single individual. And that's true for every single individual. There are also individuals who have no insurance. We can't know for any given period of time during that time, if they would have had health insurance, how that outcome may have been, how their health outcomes may have changed. And so to think about this on a larger scale, we need a large enough, and we'll talk about large enough in a bit, but we need a large enough randomized sample to have enough people in both the treatment and control groups such that all other characteristics, and this is kind of the important part, such that all other characteristics on average, can be expected to be the same. Okay, so the people in these two groups up here, they're not the same people on average. So these people, they probably have higher incomes than these people. They probably buy healthier food. Maybe they work out more. We don't know. But what we really want to compare is we want to find people with the same level of income, who work out the same, who eat the same, and all of the other characteristics, in order to compare on an apples to apples basis people with health insurance and people without. Okay, if we can't do that, then these summary statistics don't mean really anything. So we need to find those counterfactual people, and to do that, we need to have a large. The ideal situation would be to have a large randomized sample where you have a bunch of people with similar characteristics. You randomly take some, give them health insurance. You randomly take some and don't give them health insurance, and then see their outcomes. We are going to see that this actually happened in the past, and we're going to use that for looking at the causal effect of health insurance on health. But just to kind of give you some more theoretical background into how this idea really works, we're going to look at an example, a health insurance example of this idea of counterfactuals. So, if given an option, why might some choose to buy health insurance? And this is even another example of what I didn't talk about above. But think about it for yourself. For health insurance or really any other type of insurance, what might cause somebody to buy health insurance? Probably the most likely people who would want to actually pay for the insurance are the people who are actually going to need it. So people might buy health insurance if they have worse than average health. They have worse than average health, or expect they may have health problems, or expect they may have health problems. This is a general term in economics and insurance that we call adverse selection. The people who are more likely to need insurance are the people who buy insurance. And so that creates problems for the insurance company, and for the people who don't really need insurance but or expect that they're going to need insurance. But that's why a lot of insurance is actually required. For example, a lot of employers who have health insurance require all of their employees to buy in, whether or not the employee wants to. And that's because insurance companies have this problem of adverse selection, where the people most likely to need insurance are the people who are the ones who are more likely to buy it. And that's another reason why never mind. And so to continue on with this example, we're going to use kind of a stylized version with just two people. And again, this is right out of the book, so if you've read this, this can maybe help you to understand what's going on. We're going to start out with a variable yi. This is the health. It's an outcome variable. This is the health of individual I. So the subscript I stands for the person. And then we're going to add another subscript. It's either going to be a 0 or a 1. And that's going to denote whether or not somebody has insurance. So it's the health of individual I. And if it's 0, it's the health of that person without health insurance. If it's a 1, it's the health of that person with health insurance. And so, again, let me just make a kind of a technical note. In reality, we will only observe either y0i or y1i. It's literally impossible for somebody to both have insurance and not have insurance at the same time. So we only observe one of these at a time in the real world. Okay, but to explain this idea of counterfactual and selection bias and a lot of these concepts that we're going to need for econometrics, we're going to have two people. Person 1, his name is Kuzdar. So his subscript I from up above, this is going to be yi. In this case, he's going to be k. Now Kuzdar, he's susceptible. He doesn't have the best immune system. He's susceptible or prone to getting sick. And he knows that. So Kuzdar doesn't have the best, either maybe genetics, or maybe it's his age, maybe he's a lot older, maybe it's a change of environment. There are a number of possible reasons why Kuzdar may be more prone to getting sick. Maybe he has underlying health conditions, so on and so forth. So it's likely, if he's prone to getting sick, it's likely his health would benefit from health insurance. And so, again, we only observe one of these at a time, but hypothetically, let's say that Kuzdar, without 0 for no health insurance, K for Kuzdar, if he did not have health insurance, let's say that his health outcomes would be 3. Call it on a scale of 1 to 5 or whatever. But it's just a number 3. Now, if he does have health insurance, it'll improve his health outcomes for K, Kuzdar, to 4. Okay, so in his case, his individual case, the causal effect of health insurance for Kuzdar is equal to what his health would be with health insurance minus what his health would be without health insurance. That's 4 minus 3, that's 1. So the causal effect of health insurance on Kuzdar's health is 1. Now let's look at a second person. Person 2, Maria. And so her subscript I is going to be instead a subscript M. Now, Maria is young, healthy, maybe has good genetics, no underlying health conditions, and will be of the same health with or without health insurance. So if she has health insurance, it's really not going to affect her health very much, because she has a good immune system, so on and so forth. So if she doesn't have health insurance, let's say her health will be 5. If she does have health insurance, Maria's health will also still be 5. So the causal effect of health insurance on health for Maria is 0. Right, well, let me actually go ahead and write the y1m minus y0m, and that's equal to 0. Okay, so Kuzdar 3 and 4, with a positive benefit of health insurance of 1. Kuzdar, that's Kuzdar. Maria 5 and 5, causal effect of health insurance of 0. Okay, so let's look at their actual choices. What are their actual choices? So Kuzdar, he benefits. So he's going to take, Kuzdar takes the insurance, the health insurance. So YK, which is all we really observe, is YK with insurance. So his outcome is 4. Maria is not going to take, if she has the choice, doesn't take the health insurance. So what we observe for Maria's health is what we observe without health insurance, and that's 5. Okay, and so now, if we look at the difference between those with health insurance and those without, I'm going to write that down. If we examine the difference between those with health insurance and those without, what do we have? Those with health insurance, that's Kuzdar, minus those without health insurance, that's Maria. We get 4 minus 5 for a total of -1. And so actually, it looks like having health insurance reduces health outcomes in this contrived example. Okay, but if we could actually see the underlying decisions being made by both of these people, if we look a little bit deeper, we can see that YK minus YM, Kuzdar's health minus Maria's health, is actually Kuzdar with insurance. I'm going to save a little room here. Minus Maria without health insurance. This is what we observe. This is observed. But what this is actually equal to is Y1K. And if we add and subtract, so this is an equal equation all I'm going to do is add and subtract. In this case, I'm going to subtract Q-star without health insurance, and then I'm just going to add that back in. So it's the same. This is the same. Add and subtract, those cancel out to be 0, so it's the same as above. Minus y0m. And note, this is unobserved. We don't actually see this. And that's not multiplied. That's okay. What is Q-star's health with insurance minus without insurance? We calculated that up above. That was 1. Because this is 4 and this is 3. But what was Q-star's health without insurance? And Maria's health without insurance. That's 5. So we have 1 plus -2. And that's, that's giving us this final outcome of -1. But if we dichotomize those effects into kind of a little bit of a more apples to apples comparison, what we have is the causal effect of health insurance on Q-star. So the health insurance really does have a positive effect on Q-star. Plus the difference between difference in health between Q-star and Maria. And that's if they both if neither had health insurance, because of the 0. The 0 means no health insurance. If neither had health insurance. Okay, but this difference between Q-star and Maria, if neither had health insurance, exists because of their differences in health. Because of their differences in health, Q-star selected into health insurance. Okay, and so this whole term, this kind of second term here, we can really kind of call that the causal effect plus the selection effect here. And so if we just rewrite that again, and we here we have yk minus ym, which is observed health outcomes. So differences in observed health outcomes is equal to the causal effect of health insurance plus this we call selection bias. Okay, and that's because Maria did not select into health insurance because she's a healthy person. And so if we just look at the total observable differences, it's going to incorporate selection bias. And what we want to do is remove selection bias from our problems. So that's kind of the same thing as that original table up above that I showed you. There's also selection bias based on incomes, based on employment, and so on and so forth. But this is a pretty critical piece And like I said at the beginning, the goal of econometrics is the elimination of selection bias that arises from unobservable differences. So here, and we're getting a little long here, so I'll end this video shortly after this sentence. But here we have only two people, but the same results carry over into groups. Okay, and that's what I'm going to discuss with you in the next video. And then that's going to finally bring us back to this whole idea from the beginning about what it is econometrics does, and the goal of econometrics to eliminate the selection bias that arises from unobservable differences, which is the principal challenge we wrote at the very beginning of the notes: the elimination of selection bias that arises from unobservable differences. Okay, like for example, your health, your underlying health, or your age, or your income, so on and so forth. Okay, so we'll talk more about that in the next video, and I'll see you then. Thanks.